Is it visible now?
Yes, sir.
Yes, sir.
Okay. Yeah, thanks. So, topic of my today's uh, talk is handling and storage of hazardous materials.
Sir, could you please press F5 so that it would go in presentation mode? If it is not working, then fine. You can continue. Sir, you are mute. You are mute now.
My
Yes, sir.
slides are visible? Okay. So, just yeah. So my topic of today's presentation is handling and storage of hazardous materials. Uh,
Sorry, sir, your slides are not visible.
just a
Slide.
minute, just a minute, just a minute.
Yes, sir. Now visible.
Okay. Right. Am I on the second slide? Means why this topic is important?
Yes,
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 sir.
sir.
Okay. So as you know, the title of this presentation is handling and storage of hazardous material. But the question here comes is why this topic is important, and especially why topic is important with respect to this FDP of sustainable practices. So if you see this handling of hazardous materials, especially if you go for environmental performance index, because it is sustainable practices for environmental sector. So if you see the environmental performance index of various countries, I'm giving this in the order of say last to first, I will say. So India is the last one out of 180. So India is the 180th one, whereas China or Pakistan is above us. And this value for environmental performance index is like the requirements of the people with the without the depletion of capacity of the ecosystems, whereas the value for India stands as 18.9, and then China is 28, and the topmost is Denmark, where it has the value of 77.9 out of 100. So you see how we are serious about environment, and how we take it, the how we conserve our environment for the betterment of tomorrow. And this performance is of 2022, and this is actually drop in India's performance if we compare that with the year 2020. In 2020, India's rank was 160th. That one was also not good, but if you compare with that one, it is below than 2020. So this topic is important if we consider few first maybe 3-4 slides. Like I'm giving here the example of Assam oil field well blowout, and this Assam oil field well blowout, here natural gas leak occurred, and that leak was on 20th May, and the fire started on 9 June. Uh, you can see the casualties, 3 casualties. You can imagine environmental damage and the shifting of more than 1,600 families. Area affected is 6 kilometer. Compensation paid. This is only compensation to the surrounding population. That is paid is about 200 crores. And surrounding national park and biodiversity, that is already lost. And this blowout, this was controlled on 15th November 2020. So it was controlled after almost 6 months. You can see the impact of this blowout on the environment. Not only environment, why I have given this slide or this photo is you can see the impact on human beings, animals, and obviously environment.
Yes.
We see Assam or Seven Sisters as a tourist place. We enjoy there, going there. We enjoy the beauty, natural beauty. But if any accident, any such accident occurs, what will be the impact of that accident on the environment? And this is what 6 months is a long, long period. And during those 6 months also, they could not control the well blowout. They could not control the fire. They could not control the emissions from the fire that were impacting the environment. My second example, this one was the recent in that way, but the second one, that is IOCL storage, if you remember, that occurred in 2009, and which one was fire, and after that explosion was there. Casualties were 12, and breakage was there because explosion, windows breakage, building breakage was there because of the explosion. Total loss is 2800 million, and the impact of the environment is that for 11 days the fire was there. It was there continuously for 11 days. So see the impact in this case also of the environment. So if we want to go for sustainable practices, we have to see we have to minimize these accidents or the impacts of these accidents. In addition to human casualties, we have to we have to reduce the impact on the environment. This is what the popular accident, Bhopal gas disaster, just 40 years before. All we know what happened in Bhopal and number of deaths exposed, all that we very well know. Some recent or during COVID accidents I will mention here. One was the Dahej accident, that one was on 3rd June. Their casualties 8. People for around 5,000 people were evacuated. Then Vizag accident on 7th May. That one was gas spread. In the same month or next month, 29 June, again in Vizag, there was Cyanide Life Sciences factory where the leak occurred, and then casualties were 2. So these accidents, if you see, these are continuously occurring. So what went wrong for these accidents is important. Before exactly shifting to what went wrong, I'm just listing here some accidents, some old accidents, some recent accidents, not only in India but outside also. Like the popular accident is Luxembourg accident in 1974, or maybe Mexico accident in 1984. In India, if you see 1997 Vizag accident of HPCL, then NTPC explosion in 2017. So these accidents, if you Google it, you will find number of accidents in chemical industries. So what happened due to these accidents? One is environment, another is casualties, and if there is one committee and then the committee gives recommendations, and then what, for example, one accident like Vizag accident that occurred in May 2020, NGT committee formed, and that NGT imposed a penalty of 50 crores to that LG Polymers, that company. And they identified the person responsible for accident, then fixed liability, and the report was submitted. All that is okay. So accident occurred, the penalty imposed. But then what is the next? Only we have to form a committee, and then the committee will submit the report, and that report only will give penalties and then all compensations, all that is over. So that doesn't end there. Actually, that starts from there, and that starts with not only praying for that accident, but it starts with what can further be done to minimize those accidents. Next 3-4 slides, I'm giving you some data about the industrial accidents, and due to these industrial accidents, mainly due to improper handling of hazardous chemicals or due to improper storage of hazardous chemicals, these accidents are occurring. And these accidents, main causes for these accidents is like mostly half of those accidents are due to the mechanical integrity failure. Like if you see 48% due to mechanical integrity failure, and the next 27% is regarding the operating practices, failure in operating practices, and the remaining are like the control of work process or maybe inadequate hazard identification. All these contribute to the that accident. So mainly, or half of those accidents are due to the mechanical integrity failure. These are operation modes when accidents occurred. Like you can say during normal operations or maintenance or maybe startup. So during what type of scenario these accidents are occurring, and mostly 75 or 3/4 of the accidents are occurring during the normal operations, and there are during maintenance and all that also. Right? And this data we have taken from the CSB. Dr. Shailesh, is it okay? My slides are visible?
Yes,
Yes, sir.
fine. Yes, yes.
Okay, then I'm continuing.
Yes.
Okay, after this little data, this data is regarding hazardous material leakage during the transportation, because there are probabilities of leakage if during the transportation, and this transportation is like mostly 60% is. No, sorry, 50% is during the road transportation, and then during rail, marine, air transport. So these are the studies published for the transportation mode hazardous leakage. This I am giving regarding the hydrogen, the hazardous gas. So flammable gas, very light gas, and the most upcoming gas. Statistics for this hydrogen incident, what we have found in the literature is like what can be the incident location. For that, incident location is like in lab almost 40%. Then remaining is like 10% is at fueling station, hydrogen fueling station, and the remaining are at power plant and chemical plant and all that. But this is only regarding the hydrogen leakage. And if we see accident for equipment, then we can say that mostly the leakages are from piping, fittings, walls. So these are almost 1/3 of those accidents are from these leakages. If you see probable causes, this is interesting. Probable causes is not only human error. Human error is around 15% only, but equipment failure is contributing to 1/3 of those accidents. And damages and injuries, if you see, property damages are almost 40%, and then the remaining minor injury and then the loss of human life, all that is coming. So this is only for hydrogen. Okay. This is for major accident hazard MAH units all over India, and there are around 2,000 major accident hazard units, and in Gujarat and Maharashtra are having the highest number of MAHs compared to other states. So we are mostly at more risk being in chemical industry surrounded area. But if you see this chemical industry market in India, it is continuously growing. India is the 6th largest producer of chemicals in the world and 3rd in Asia, contributing to 7% of India's GDP. And, market is around US $300 billion by next year. It may touch, the case is that it may touch $1 trillion US dollar in 2040. And obviously, growth is, if you see this graph, growth is more than 10%. It is good that the growth rate is more than 10%, but at the same time, if we go for this, there should be a sustainable growth for this one. This growth is there, but that should be sustainable in terms of the environment or in terms of the energy sector. And this is the framework for the environmental sustainability, where the stakeholders, basically government, companies, and then NGOs, households, all those will be the stakeholders. And the The problems with the environment, as we all know, climate change, GHG emission, air pollution, what all those air components or the environmental component pollutions, and then the environmental governance, policies, plans, acts, laws. So all these are the stakeholders in this framework. So in our presentation, we are looking after these two, the right side two parameters. One is environmental problems, and those environmental problems due to the handling of hazardous chemicals, and one is handling, the other one is environmental governance. What type of governance is required, and to what extent it is necessary. So we'll mostly concentrate on these two parameters. So if you see all these slides, if you see accidents occurring all over the world, in India during COVID time, and after also COVID time, it is continuing. So what is the solution to this one? And it is not that we stop handling chemicals or we stop storing chemicals, as Indian chemical market is increasing. So what can be the solution to minimize its environmental impact? So I will give these solutions in terms of 3-4 important points. One is the accurate assessment. So whatever is we are doing, whatever we are handling, whatever we are storing with respect to hazardous chemicals, accurate assessment is important. Then the question comes, assessment is of what? So assessment is of hazard identification, for example. So we should accurately have that this is what the hazard is, and this is what the level of that hazard is. And if in case of leakage of that hazardous chemical, what can be the impact to the surrounding population? What can be the impact to the environment? Or what can be the financial losses? So most important part in this is assessment, and that too accurate assessment is very necessary to control the environmental impact. The second point, we will see in detail what this accurate assessment is. The second important point is implementation. If we have some industry, if you have some setup, if you have some unit, so exact implementation is important. Exact in the sense, implementation as per rules, implementation as per the laws is important. And that is not, the implementation is not one-time activity, it is day-to-day activity, and we have to monitor that continuously. This is the second important step in these solutions. The third is precautions and rules and regulations. So while once we have set up, once we have accurate assessment, in addition to that one, precautions are important. Precautions like measures, I will say, measures are important in handling, in storing, in processing those chemicals. Because precautions or lack of precautions will lead to accident, will lead to your mismanagement of that accident, will lead to your assessment, not correct assessment. So precautions will be important. And the last and important solution to this is quick and efficient management. Even if we are taking, even if we have the correct assessment, even if we have implemented it perfectly, even if we are having all the measures implemented correctly, but even if there is any accident, even if there is any leakage, even if there is any fire, even if there is any explosion, any toxic release, quick and efficient management is important. So handling that accident in a quicker way is important, in addition to above points. Above points are important, but even if we have the above points and even if there is any accident, we should have the quick and efficient management is important, so that we can minimize the impact of that accident to the surrounding population as well as environment. Now, in this, how to go with this accurate assessment? So that accurate assessment, I will say that as a hazard identification, risk assessment, hazard assessment, safety assessment. So you can name it anything, but the assessment regarding to that hazard assessment regarding to what will happen due to the release of that hazard, assessment regarding what will the impact of that to the surrounding population, even if it happens in the morning hours, even if it happens in the afternoon, evening hours. So what can be the accurate impact, or even if it occurs on working day, even if it occurs on the holidays, Saturdays, Sundays, so what will be the impact? So that impact we can say in terms of risk assessment. So that impact we can have not only in terms of only consequences. We say that if this happens, the consequences are more. But at the same time, we don't have to only look at the consequences, but at the same time, we have to look at what can be the probability of that accident. In some cases, it may be possible that consequences are not, right? But at the same time, you see what can be the probability of occurring of that accident. So when we assess, when we want to assess that correctly, so both these parameters are very important. One is the impact, consequences, and what can be the probability of occurring of that. Once we have this one, the other important thing in assessing it correctly is like what can be the probable events, like determination of events that can produce an accident. Like if I have storage of chemical, that can be the leak from that, there can be overflow from that, and due to that overflow, spillage can also occur. So all these events you have to list it out. And then based on these events, what can be the consequences out of those events? And the process of increasing one's understanding of the risk associated with that accident. So once we have that impact, then we can educate the people in that area, in that industry, about what can be the risk associated with that activity, with that unit. So the first is risk assessment. Like I will say, I will give this hazard and risk. So if we go to park and there is a tiger in the cage, we are safe. So why we are safe? Because the hazard is in the cage. So it is in the case, so we are safe and we don't worry about that one, right? We freely move in the park and all that. But if this happens, if tiger is out of the cage, like if the hazard is out of the control, if the hazard is moving out of that limit, then there will be a risk. So this we can say that this is the hazard, the tiger is hazard, we agree, but the risk is when that hazard is not properly stored, when that hazard is not properly controlled, when that hazard is not it's left as it is without any precaution, without no monitoring, so the risk will be there. So due to these accidents, this is not that only fire and explosion, not only fire explosion, there is one more, toxic release can also happen due to accidents. So fire explosion and toxic release, and consequences, you don't only think of casualties, fatalities, you don't only think of environmental damage, but at the same time you have the property damage. Even plant closing is also there due to that accident, and that will cost a lot to that company. Even fines, lawsuits, and that lawsuits will go for years. So these are also additional consequences in addition to those fatalities, injuries, and then environmental damage. So in this, to have this accurately, what can be the process risk assessment flow chart? Like I said, the hazard identification is important. So once we identify the hazard, then the consequence analysis, that is what the impact is, and then frequency estimation, what the probability of that is, and then combining these two will give you the total risk. But once you get that total risk, suppose risk, you are saying that, oh, we got the risk, we assessed that, we did modeling, all that we did, and we found that this is hazardous, this is risky. So then that risky part, that risky unit, how to have the precautions of that risk unit so that it can come into the acceptable limit. So from that management is important, and that is required precautions to limit consequences or the measures to reduce the frequency. So these two can be taken to reduce that accident impact to the acceptable limit. So that can be done. One of the ways to do that is process parameter optimization. So these are the phases of risk assessment. One is hazard identification, hazard quantification, and risk evaluation. As there is no need to go in detail of this hazard identification, there are various methods to identify hazards. Engineering course, practices, safety checklist, hazard analysis, fire and explosion index calculations, toxicity index calculations, all that is there, historical record analysis. So all these are the methods to identify hazards. Once is identify hazards and then quantify hazards, because once we know that this is hazard, but what is the quantity of that? How hazardous it is? So that hazard quantification in terms of consequence analysis, vulnerability analysis, fault tree analysis, event tree, and there are various methods available to quantify those hazards. And the final is risk evaluation based on this identification and quantification, which has the these three methods are integrated. So I'm saying fire. So fire is not only one type of fire, so called. It can be 3-4 types of fires are there, like pool fire, flash fire, or maybe jet fire. So all these fire will we have to see which type of fire is possible in case of accidents from that. So that is also comes under the accurate estimate of your hazards. So then you divide that into pool fire, jet fire, all that possibilities of that. Then explosion. In case of explosion, also this is not only one type of explosion that will always occur in case of any vapor cloud explosion. So or it can be Blavy or it can be condensed phase explosion. And the impact of that is obviously explosion. If it's there, that impact can be blast wave. And then toxic dispersion can also be possible, where we have continuous, for instance, release. So based on this one, you have the impact, like for in case of fire, you can have thermal radiation, then explosion, you can have pressure waves. In case of toxic release, you can have toxic gas dispersion. This is regarding if in case of accidental release of hazardous chemicals, what can be the phase of that hazardous chemical release, and then that release will occur to what can be the impact of that. Like if you see this, the left is like gas release with high velocity, that can be the possibility, as it is high velocity, possibility of jet fire is there. So this will give you the way to classify the jet fire, to classify fire, to classify flash fire, or in the case of explosion, how to classify those scenarios in case of accidental release of hazardous chemicals. Like if there is a liquid, then the possibility of pool fire is there. And then that also depends on the type of ignition. And if in case of cloud formation, if it gets ignition, then there can be the possibility of vapor cloud explosion. And if there is no ignition and the gas is toxic, then we can say that can be the possibility of toxic dispersion. So this flowchart will give you the type of fire, explosion, or toxic release can be possible from that hazardous release. So just next maybe 8-9 slides, I will give you one case study where the hydrogen release is due to the not due to the, I will say, but hydrogen release from the hydrogen refueling station. So this is hydrogen refueling station with the compressed hydrogen, and then it is condensed, and at the end it is on board tank. It is filled in the vehicle. So during this one, this HRS, I will say, hydrogen refueling station. This HRS, if you see this map here, this HRS is this point. This point is HRS with dispenser and all that. And to this HRS, there is this expressway to this side. There is internal road to this side. What is next is LPG fueling station this side. So you can see this hazard identification in this one. So this is hydrogen that is we are handling. To that handling, the surrounding is these roads with vehicles. these vehicles, and even the one more hazardous situation surrounding this is LPG fuels. So fairly hazardous situation, and anything can occur in case of leakage of that one. And there is obviously some small buildings that are operating room and all that, offices and all that. So from this one, we will see what will happen in case of release of hydrogen from that hydrogen refueling station. And in case of release, we will consider two scenarios. One is catastrophic rupture of that tube trailer, which has the pressure of 100 bar, and the other one is leakage from that dispenser. So in case of catastrophic rupture of tube trailer, explosion is the scenario, and then in case of leakage from dispenser, fire scenario is considered. And these explosion or fire scenarios are assessed in terms of the heat radiation levels and for fire scenario, and pressure waves in for explosion scenarios. And for this fire scenario, if impact is heat radiation, and the heat radiation, if you have the heat radiation like 1.6 is no discomfort for 1.6 first degree burn is for 4. 1.6 is just if we go and stand outside in summer, then whatever heat you are getting, that is mostly at the 1.6 kilowatt per meter square. 4 is first degree burn, 12.5 is minimum energy required. So these are the standards to identify to have the heat radiation assessment levels in case of fire scenario. And like 37.5 will have damage to process equipment, where the damage to people is like 100% lethality in 1 minute and 1% lethality in 10 seconds. Similarly, for explosion scenario, these are the pressure wave assessments. Like if there is a pressure wave, it is obviously more than atmospheric pressure. So it is, if it is 1 to 1.33, 50% air temperature chances. If it is in between 3.5 to 5, then 50% lethality chances, and 5 to 8 is 100% lethality. This is in terms of human injury. Same for structural damages. If it is 0.01, it's a crack of windows only. 0.3 is damage of glasses. So all that is given for the peak overpressure and the type of damages. Our experience is like, in case of explosion, fatalities are more. Why the fatalities are more in case of explosion is due to the collapse of roof. Even though those human beings are within the safe zone or within the that room, but due to the explosion, the collapse of that roof will have the more fatalities if you compare with the fire. So explosion is in that way is more dangerous than the fire. In case of fire, at least you will come to know that this is the fire and will run. But in case of pressure wave, in case of explosion, there are chances for you will get less time for evacuation. And then it gives
Sir,
this.
one question, sir.
Yeah.
What quantity of the fuel, it may be a liquid or a gaseous fuel, that could be stored, which could not cause any kind of impact later? So minimal quantity, it should not exceed the quantity, maximum quantity, which once caught fire and any kind of blast or blew should not cause major damage. Is there any such data that is to be mentioned?
Yeah. As such, there is no data for this.
Because
And
I read one incident, which is a Bhopal gas tragedy, where the methyl isocyanide was stored in a large quantity as compared to the limitations, because of which there was a mishap.
okay, good. Uh, See, as such, there is no regulations for the minimum quantity. Why there are no regulations? Because if in case of explosion or in case of fire to occur, it will occur even if it is small one, it is even if it is large one. But in case of small quantity, the handling of that fire will be obviously easy than the larger quantity. But as such, there are no standards, because as per that chemical industry's requirement, they have to store that. So we cannot say that you only store 100 tons, you don't store more than that, or you store less than this. This is not possible, because they have to run the operation continuously. So this is not given. Okay, what they have given is like the distance between two storage tanks or the distance between a chemical storage tank and boundary of that pore. That is given, but the quantity as such limitation is not. And that distance, I'm saying that distance is given in terms of the capacity of that storage tank. That is also given, but they are not giving that you only store this much and don't store above that. That is not okay. Then and again I will come to those regulations. What are regulations available in India? This is like individual risk that obviously the name suggests the risk to one person, and this is given in terms of the risk contours. This is like this is given in terms of risk contours and the number of fatalities per year, frequency per year. Then the other risk is given is in terms of societal risk, where the risk is to the society more than one. That is given in terms of three reasons: where it is acceptable, not acceptable, or in the ALAP region. ALAP region is a region that is in between, obviously acceptable and acceptable, and where you can have the precautionary measures to control that risk. So this is what the tolerable, acceptable, unacceptable, and right. So this is what given, and these standards for this alarm or these acceptable limits are given by different countries. Like Singapore has also given, UK, European countries, Malaysia has also standards for these FN codes or for this societal. So once you assess that risk, so you just see that risk from that one is falling in what region, whether it is falling acceptable or in between, or so accordingly you take the next steps, precautionary steps. LRPs, it is in between the two regions and where you have to take the precautionary measures. So we are saying that the accurate assessment is required, but there are various parameters involved while correctly assessing that risk. Those parameters, like you have to take all the conditions throughout a day, like the accident can occur in the morning, so wind velocity according to that one, atmospheric stability class according to that one, or may occur in the evening hours also. So anytime is possible. So all these probabilities, all these scenarios you have to consider based on the atmospheric stability class, location of ignition source, wind velocity, and population density also. While assessing this risk, surrounding population is also important, where while getting the data on surrounding population, you have to see whether indoor population, outdoor population, or the accident is at the night or in the daytime, because daytime outside population will be more, at the night time outside population will be less. So all these combinations you have to see, and then you have to give this one with the to get the assessment. So in case of this HRS, hydrogen refueling station, the leak has occurred, and then these contours are giving the impact of that leak, these both catastrophic rupture as well as leak. So giving impact, this inner circle is, the green one is 37.5 kilowatt per meter square, that is heat radiation due to fire. The outer to that one is 12.5 kilowatt per meter square, and the outermost is 4 kilowatt per meter square, where we have first degree burn. So these will give you the impact due to that leakage to that point. This is fire, this is explosion scenario, where we are given in terms of pressure waves. This is what the pressure is generating, 0.2 bar. Here 0.14 bar is generating here, and these are the contours for this one. So this is for the explosion scenario, and the impact of that one given. Now the risk quantification based on probability as well as the consequences. So this is this impact with these risk 10 to the power minus 3 is generated maximum. So 10 to the power minus 5 is also touching the expressway. If you see this one, this is 10 to the power minus 5, this one, this is touching the expressway. So the risk in this case, the individual risk is touching this expressway. But this we have computed without any mitigation measures. What will happen to societal risk in this case is without mitigation, where it is falling here. So it is unacceptable here. So it is falling in this unacceptable. So
Sir, will the explosion, sorry to disturb.
Yeah.
Will the explosion depend upon the type of material used for storage of any of the chemicals?
Yes.
Because
Because
if we are using any storage devices, instruments like made up of some materials like metals, that may cause bulleting after
yes,
explosion.
yes. Uh, there are two things. One is depending on chemical also, explosion will change. The impact of that explosion will change. And you are saying material of that storage tank or what?
Exactly, sir. If the material is made of metal, the
Okay.
strength of the metal is lesser as compared to any other material which is non-metal,
Okay.
like made up of fiber, Kevlar fiber or so, which is more stronger than a metal.
Yeah.
That could have reduced the impact after explosion.
Yes. Uh, that's fine. That impact will reduce. But I'm saying that probability also we have to take into consideration. So obviously probability will change depending on the material of that storage tank.
You have shown that in the image a blue color circle and a red color circle.
Yeah.
That is the radius where it gets the impact
Yeah.
after explosion. Is it
Yes.
with respect to any metal or the storage the storage device, like whatever the storage it is made of, a metal or it may be a fiber? Is it dependent on that material or is it simply diameter which is assumed to based only upon the pressure?
While giving inputs for this assessment, you have to give all these inputs like what is the chemical, what is the pressure in that, what is the temperature in that. At the same time, you have to give what is the material also in that. Material they will consider while getting the probability for that accident. So all these parameters we have to give, and based on that one only we assess these scenarios. So all these inputs are important. And in addition to these chemicals or these metals, or in addition to these temperature, pressure conditions, we have to also give them the population, surrounding population also. So based on that one also, it compute the consequences.
Okay, sir.
So all these inputs are important. When we used to carry out these assessments, to be on frank side, the major problem we faced is not with the modeling, not with that software and all that. The major problem we faced is to get the inputs from the industry. Because whenever we used to ask inputs to the industry, either they used to say that you assume it, or they did not give correct inputs because they want it to be minimized one. So the major problem is to get inputs from the industries. But this is based on the accurate inputs from the industries, and all these inputs are required for this assessment.
So will
And
this need a multidisciplinary technical people, or anyone like a chemical engineer alone cannot do it probably?
yeah, actually, when we say HAZOP or when we say all these assessment, it's a teamwork. Teamwork means I'm saying not teamwork of 4 or 5 chemical engineers only. It's a teamwork of mechanical engineer, then instrumentation engineer, and then electrical engineer, and then obviously chemical engineer is required. So this is a teamwork of different disciplines.
Okay, sir.
Um, so these with mitigation, it is showing less if we compare with the 10 times lower than the without mitigation. So for this without mitigation, it is coming 10 to the power minus 3. So here it is 10 to the power minus 4, which is touching to the that which is the maximum generated. So 10 times less for the mitigation. Same, if you see the previous one here, it was falling in the unacceptable, whereas here it is falling in the alarm region. So with mitigation, obviously it is falling in the alarm region where precautionary measures are important. These we have given in terms of numbers, without mitigation, without any safety barriers, what can the frequency generated for tube trailer as well as a dispenser. Like here it is 10 to the power minus 4, minus 7 on that. And uh, here without yes and no, here if you see here barrier no and yes, so based on that one if it is yes, obviously the assessment or obviously the risk generated will be less. And all it is given for IR and SR, individual risk as well as societal risk. Now, I'm saying that we have to give inputs, we have to get inputs from the industries, but which softwares are available for assessing this risk? Generally, in India, FAST, Safety, or Aloha, these are the softwares available in carrying out these risk assessment studies. And these softwares are widely used in India, even acceptable to regulatory authorities also, like MOEF, maybe for Maharashtra it is DISH, or state environmental agency. So for all these software, fast substitution law are acceptable to them. The studies carried out based on these softwares are acceptable to them. The other softwares available are like PHA Pro is also available, QRaverse, Discourse, all these softwares are available. But the problem with these softwares are these are 2D models, and these don't account for the buildings and obstacles surrounding the plant, because building and obstacles play important role while assessing the risk. Even overestimate. So in this case, if there is no obstacles, there is no building surrounding to that one. That is what we consider while going for 2D modeling. So the impact will be overestimated, or in that it is wrong, because wrongly we are giving the distance of say 1 kilometer or say 2 kilometers, which is obviously will not go. The impact will not be up to that distance, but using 2D models, we are getting those impacts. I'm giving here in terms of these damage contours at various hit radiation levels. So the solution to this one, or the most updated to this one, is 3D models. Those are also available nowadays. And those 3D models, like if I go with the model name is Flat Software, that is Gibson developed software, that is also available. In addition to KFX model that is given by DNV company. But what is the beauty of these 3D models is obviously 3D representation of the results. In addition to that one, the main is it considers the surrounding building obstructions and topography. So, so it doesn't give overestimated results, whereas it gives more accurate results than the 2D models. And then obviously, as for the 3D models, it uses distributed porosity concept, all those equations, all that, and even it suggests the locations of gas detectors, control rooms, and pumps. So this is better than obviously 2D. But as I said, we face problem in getting the inputs from the industry. If we go for 3D models, the inputs required are more, like surrounding population is required. Sorry, not surrounding population, surrounding buildings, obstacles are required. So to get that data or to get more data is maybe the problem with this 3D modeling. And more inputs, and geometry is bad, because if we get the surrounding say buildings, or maybe surrounding meat, or maybe surrounding building, or trees also are also important, because trees may trigger your explosion activity, because due to trees, the whatever leaked gas will be within the campus, within that plant campus, and it may trigger to the more impact. So the trees, surrounding trees are also required as inputs for these cases. So this is the problem with the 3D modeling. But accurate results will get if in case I'm giving here for 50 leak and pool fire scenario. In case of 2D model, that is the left one, where the impact is too far, it is touching this line, it's touching this line, whereas in case of 3D, it is only touching this PRU unit, or maybe this unit. So PRU and this HM unit, hydrogen manufacturing unit. So it is only touching these two units, whereas in this case, it is not only touching, it is crossing and then going to the crossing that unit boundary and then touching to the next unit. So these are the overestimated results, whereas these 3D models will give the more accurate results in case of 3D and 2D comparisons. And obviously 3D will give you cost-effective decisions for the emergency preparedness. So this is the useful than 2D. This is for hydrogen safety investigation, that the studies we collected the literature, and we have found that recently, I will say, 3D modeling studies are more published. Those contains 86% of the studies what were published is for the CFD based 3D modeling, and 2D are only 14% as per the literature published. In that 3D modeling also, Flax software is 1/3 is used. Fluent is also used for the 29%. So these are the 3D modeling assessments. Okay, so this is the case study. This is the assessment. You accurately calculated that assessment and all that you have done. But how to prevent those accidents or losses are also important. So this is the before the accident. What can be the precaution or losses to be taken? Some of the precautionary measures I will just highlight here. Like one is geotagging of your MH unit, so that easily you will identify the hazardous chemical. Easily you will identify the where is the unit and at what location it is and how to go there at the earliest. So these can be possible with the geotagging of MH units, and NDRF and all that has at some units there, at some places they have the geo tagging of this major accident hazard units. So this is one of the way to tackle that one in minimum time. Like they have this they have the geo tagging and how to have surrounding population, to what extent it will go. So all these studies they have with them, so that they can easily get the location details. Vulnerability mapping in case of natural disasters, in case of coastal states, preparation of hazardous map or preparation of disaster probability forecasting, vulnerability risk maps can be possible. That can be done as a precautionary to that studies. Then where are the flood prone areas, landslide areas, fire stations, where are the government hospitals, PSCs, relief center? All these data if we have, it will be easy to give that injured as early as possible the treatment. Okay. This slide will give some answers to the question that has been asked just now. Guidelines for the risk reduction. There are OIC guidelines, and those guidelines given for the oil storage and handling, hazardous chemical data, process control room safety, fireproofing in oil. For all these guidelines are given. In addition to that, NFPA guidelines are also given. So these guidelines are generally accepted in the industry. Even for layout for oil and gas installation, there are guidelines. So in addition to these guidelines, there are important is obviously PPs. PPs are very important. And these PPs, but only having PP is not important. What we have observed is in some of our industrial visit, what we have seen is they have the PPs, but they are not using it. So only having PP is not useful. You have to use it, and you have to use it accurately. So this is what is more important, and for that, the training programs play important role in understanding or in educating them how to use that PPs and what or which PPT is for which type of taking care. So that is also important. So here, like PPs, it is eye and face protection, head protection, what is the workplace hazard, what is the suggested PP, and how you can save yourself by using those PPs given in this slide. This is a general one, so I'm not taking too much time on this one. In addition to suggesting those PPs, because PPs are very important, like in our, I just give you one example. Like for these PPs, ours is the research laboratory where we have lot of chemicals. I will say when number of chemicals, different, obviously different properties, different flammability range, different exposure range, all that one, and some minor accidents occur in this institute because of PhD scholars handling those chemicals during their PhD and all that. But having PPs have saved a lot of injuries in our institute, as well as not only injuries, but in case of some small fires, training to them have also helped a lot, because they themselves can dose of that fire. It has been observed that many a times these research scholars operate that fire extinguisher and then they dose of that fire. So that is very important. Training is very important, and not only training, but how to practical training is important, because we have regular training sessions, and in that training sessions we hands-on practice is important, and we train them hands-off dosing of that fire. So that is what is important. In addition to those PPs are required. And in case of these risk assessment studies, in case of this handling of these hazardous chemicals, specific recommendations are also important. Like for specific chemical, like for chlorine, what is this requirement? If you are handling chlorine, what can be the requirement? So these requirements are also one part of those studies if we are handling this specific hazardous chemical. In addition to general PPE, general precautionary measures. This is again one of the general slides that I have put here. Firefighting facilities are important. All these firefighting facilities, water supply, fire hydrant line, mobile firefighting equipment, fire detectors, all that is important in case there is any accident and to tackle that. Not only important of having that, but at the same time, one more important thing is it should be operational. It should not happen that we have fire extinguisher, but that is the expired one. The expiry date is over maybe by 1 year or maybe 2 years, so that is not required. So having only that is not required. Same time we have to say whether it is operational or not, and the maintaining that or maintenance of that is also important in handling, in tackling those storage tanks. Because many a times what happens is that the industry purchase those firefighting facility, industry purchase those fire extinguishers and all that, but they keep it for years there without doing anything, without maintaining, without checking, without any seeing that fire extinguisher. And then at the same, at the time of accident, then it's gone all the way. Some rules and regulations that I will not list out this one as faculty, you know, all these rules and regulations, factors, disaster management act, chemical actions, all that they have. Okay. But one more important part is like modeling, analysis, or assessment, or precautions are sufficient. No, the third and the last point is having the management. Emergency response plan, disaster management plan is also important, which gives us the safety of the people, protection of the environment, advanced planning of any emergency, and then rescue, relief, and assistance to the affected people is also important in giving this emergency response plan. Major objectives of this emergency response plan, obviously, establish a effective system for detection and reporting of leakage, because reporting is also important, so that quick action can be taken. Facilitate rapid and effective response to accident, and then rapid measures to be taken. All that are the objectives of the emergency response plan. And this is not only with the chemical release scenarios, but in case of natural calamities also, we have to handle those emergencies like earthquake, cyclone, flood. So all these cases also, based on the type of emergencies, actions will be taken. And for man-made is fire, explosion, toxic release, somatage, all that will be the phases of emergencies: warning phase, period of impact phase, then rescue. So warning phase is important, where all these can be evacuated, or all the precautionary measures can be taken, assuming that the accident is going to happen. So warning phase is very important and plays a crucial role in tackling that accident. Because period of impact phase, all that will come later on. The rescue, relief will be this one, but warning is important. All of these phases. On-site emergency plan, what should be there and what not should be there, emergency control room, assembly points, all that is important. At the maybe after 4-5 slides, I will tell you just interesting points we have observed while conducting all these emergency response plan activities or mock drills. Reporting procedure, that nearest telephone, all that is important. Name, you have to name your name, all that. Reporting answer should be at the location, tell the exact location of that accident. All that is normal activities and known activities, I will say. Assembly point. See, we say that, or all we know that assembly point should be there in that industry premises, but the location of that assembly point is also important. Because what we have observed in some industries is that assembly points are located just on the roadway, or it is located at the entrance of that building, entrance of that unit. So the location of that assembly point is also important. Because in case of accidents, if all staff, all employees are assembled at that point, it should not block the any vehicle. It should not block, for example, firefighting vehicle also. Because in some cases we have seen that people have gathered at that point in case of emergency, but the assembly point is such that there is no space for the firefighting vehicle to come too close to that unit. So the location of that assembly point is also important, in addition to accurately giving that assembly point and all that. An up-to-date list of pre-designated employees of various departments should be available at that time. So these are, even though we know all these one, but you get these based on your experience, based on your conducting all these activities. Small precautions what is to be taken. Offsite emergency coordinators, district collector is offsite emergency coordinator, which declares that it is emergency. Contact media person, all these other departments are also important in case the impact of that accident is outside the plant premises. So which are the important? These are the government departments which are responsible, which are required in tackling these accidents, like police department, medical coordinator, revenue, telephone authorities, education, all that, inspector of factories, transport authorities. These are the important departments required to tackle that offsite. One more important
Sir,
point. Yeah,
one doubt, sir.
yeah,
In the previous slide,
yeah.
you have a list of officiating people off-site, means they come under the district collectorate office or under his authority. And in case of any accidents that could have occurred in the premises and people are not able to handle that, and off-site emergency officials, will they be provided the training? And they are in a floating process, all the officiating people, they get transferred, they get moved from that place. How often the training has to be done?
One thing is that the base remains same, even if they are getting transferred. But the basic training given to them to tackle fire, to tackle explosion is same, or to tackle any disaster is same. Whether it happens in Maharashtra, whether it happens in Pune district, whether it happens in Nagpur district, anywhere, whatever is basic required, that is given to all that senior or whatever may be the officer. So even if they are getting transferred, but the basic training is given to them. One thing is that. The second is training. Mostly it is said that 6 monthly training is required, because every 6 months you should have training to that one. Even if you know that what is to be done, but still you should have the training to that one. You should have hands-on training to that one, so that you will just
Sir,
have
every industry has got a different handling technique based upon the chemicals used there.
yeah.
So how can those non-technical people like police or revenue department can handle this?
Okay. So in that case, they will not have the inside plant handling. What they will handle is whatever is required to them, and they will provide to that. That infrastructure they will provide to that. But exactly handling chemical, exactly handling that will not be done by this police department. Like, I will give one example. Like in case of fire, which type of fire extinguishers they have to use, which type of fire facility they have to use, that plant person will only will know, and they will have to just inform them that this is what the fire, and this has caused due to, probably due to this, and then you have this type of firefighting facility. So the infrastructure required to that one will be provided by the offsite agencies. Like in case of our fire, you said it occurred in 2017. So in that case, probably we knew that this may be due to that one, so we provided information to that one. Then only based on that one, we only tackled that one initially, and then we took the help of the offsite agencies. You are correct that they will not know that what is that chemical, the fire is due to what, but they will provide you infrastructure as well as whatever is required basic for that one. They will obviously will come to
Okay, sir.
that. Yeah. One more important thing that what we have observed is educating surrounding people is very important. Maybe by distributing pamphlets, by giving training to them. All these are the important steps in educating surrounding people. It should not be the case that only industry has come, they are happy, they are getting jobs, they are getting all that one. Is not important. At the same time, if you are handling hazardous chemical, if you are having storing hazardous chemical, surrounding education, educating surrounding people is very important. If you see in case of Bhopal, in case of Vizag, surrounding people should know what precautions to be taken in case of any accident. General precautions, basic precautions. They will not come to know what gas has been leaked. They will not come what has happened. But at least basic precaution they should take care, so that at least they will save their life. So that is what is important. Basic training is very important to the surrounding population. Obviously, training, hands-on training. I'm not only saying training, hands-on training is important. Only pass is there. If you know, pass is there for fire extinguishers. Only knowing that pass, pool, and all that is not important. What is important is you should know, you should handle that one. Then only it is useful. Then only it will be beneficial to that industry. And one more, safety mock drills. These safety mock drills are also announced, and unannounced safety mock drills are also very important. Why I am saying these are very important? I agree, in assessment, exactly knowing the risk assessment, there may be some chances of overestimation or below estimation because of the inputs provided. That we agree. But to tackle that one, these are the important steps even than assessment, because at the end, no one will go to that report and see that the impact of this one is up to 1 kilometer. So the population up to that 1 kilometer should be evacuated. Or that no one will see in that disaster situation what is in the report. But the education, the management, the what important steps to be taken to minimize the impact of that accident are important than all these assessment or all these detector systems. So announced and unannounced mock drills are very important. Initially, you can have the announced mock drills so that they will come to know what is time to be taken to evacuate that building, where to assemble, how to assemble, what not to do in case of mock drills. So all these are important steps in educating the plant personnel for that industry. Like we conduct also 6 month this unannounced mock drill, and we have very interesting observations over the years while conducting this one. One important observation that we observed is one research scholar was working in the lab, and then we have that siren and all that for emergency. He came out of that his lab, but at the same once he came out, immediately he went inside after maybe 1 or 2 minutes, and then we asked him why you went inside after coming out of that room. What he was saying that I wanted to bring that laptop, that's why I went to that lab. So in case of emergency, nothing to be done. You have to left whatever is there on your table. You have immediately come out of your lab. Our second observation is like when people are coming out of their lab, out of their industry, what they are doing is if they come to know that this is announced, what they do is they will check their mobile, their whatever, maybe WhatsApp, Facebook, whatever. They check that social media while coming out of that. So this should not be there. Immediately you have to come out of that, and only you have to inform your colleagues. You have to inform your whatever you are surrounding people. You have to inform them, and you come out of that room. Even for physically handicapped person, also you have to take care that they should come out of the that unit. So, one more observation is one person was using lift. Actually, lift should not be used in case of any emergency. So he was using lift. So these we have come to know from these experiences. One thing is that medical team did not arrive within the time. So we just give lessons learned to them so that next time at least they will come within the time. Like say 3 minutes, 4 minutes, they should evacuate all the building and medical team should come. In one scenario, the firefighting vehicle came late. In one scenario, it was not giving siren that it was coming. In one scenario, assembly points, people did not gather at the assembly point. So all these are coming over the experiences that we have seen for these unannounced safety mock drills. This I will not go. These are the regulatory authorities, DISH, DGs, and OSD, all that are the regular that we all know, these regulatory authorities. So what is the role of policymakers? Because in this case, policymakers are also important. So what is the role of these policymakers? They should have the reliable database. One thing is that, like factory inspection, they should have frequent inspections, proper investigation of the accident, and awareness with the continuous training consequences. All these are the responsibility of policymakers, because policymakers also play important role in minimizing those accidents, or in minimizing the impact of that accident. Next 2 slides I will give the data, and that data we compare with India and the developed countries like UK, European Union, US, China, all this. And what we have found is fatality wise, UK, UER, they have less number of fatalities per accident, whereas India and China having more number of fatalities per number of workers. And number of accidents reporting, all that is more over the years for the India or China. This is about the process safety regulations. As I said in that societal risk slide, there are regulations available for Singapore, Malaysia, UK, and all that. But we don't have any process safety regulations, assessment regulations, I would say, how to calculate that impact of that accident. So those regulations are not available, and whatever is available, that is needs strengthening. And if you see this table, where A is like well-established implementation procedures, B is at the latter phase of development and implementation, whereas C is mostly it's not there. If you see with process safety regulation, compliance audit process, or maybe in case of reporting of fatalities or reporting of loss of containment, for all these one, if you see, India mostly falls in C category, that is not available or in the early phase of development. So this, at least we have to shift from C to B to get it more implementable. And
So what is the
regulation.
main cause? Sorry, I'm interrupting repeatedly.
What word? Pardon, please.
I'm sorry to interrupt repeatedly, sir.
Yeah. Continue. No issue. No issue. It's
What is the main cause for India having that category C? What in your
yeah.
vision? What?
Yeah. I've given that one of the reasons I've given in the limitations. In India, instead of writing this one, I will tell you one thing. In India, there is one chalta hai sort of mentality. So that chalta hai sort of mentality should not be there. So even if we have any hazardous situation, what we say, "Arey, chalta hai, chalne do," sort of thing. So it should not be there, and should not be there for this type of scenarios where the impact will be too much, too high. So this should not be the number one. The number two is in India, see, only one factory inspector for 506 factories. So for 500 factories, if only one factory inspector is there, how can he or she will handle the inspections of those factories? 500, how will he or she will go to that factory inspect? So manpower crisis is also there in India. In addition to that one, lack of considered data restricts the development. Because data, what we have seen is they don't give data. Even if we want to carry out that risk assessment studies, we have asked n number of industries, n number of times also to give accurate data. They don't give accurate data. Even say known industries, popular industries also, public sectors also, they don't provide exact data. Don't know whether they're afraid of these studies or whether they're afraid that something will come out of this study. Don't know, but they don't give the data. So one is that, another is manpower crisis, and the third one is mentality that is required. Mentality is very much required because that is what from where we learn from this. If you go to Japan, they see their discipline, whereas if you come to India, you can see the same person's discipline. So that mentality and all that parameters are very important in this one. And even manpower is also necessary. One more thing I want to highlight here is that even during our graduation also, this process safety or this process risk assessment is not considered as a favorite subject during graduation days. It was offered as a elective subject, or not serious, maybe in the final year, and maybe very few students are opting for this one. So that changes should come at the educational institute also. They should have these subjects regularly and should be offered at a routine course to all the students. That is also required. So this is what in process safety evaluation, in process safety and risk management methods. So in 1960 to, you can say, 2020, about 2020, slowly we are going to management focus, then safety management, safety culture, and then resilience. So safety culture is very important. That one. Then only if you know, if you follow that one, then only others will follow. If you don't follow, others will not also follow. That is what is important for this. These 2 3 are general slides where we have the stakeholders. What can be the stakeholders for these studies? All these petrochemical industries, chemical related and allied industries, MOEFCC. Even one more experience, what I will say is these policymakers or all these permitting authorities, even if in case of permitting authorities, they don't see these studies very seriously. When you submit, say for example, environmental impact assessment report, where it contains the risk assessment as one of the chapter, so in that also not that seriously is been taken for this report. So only this should also be there, so that something strict from their side should come to that industry, then only they will follow. If there is no strictness from them, then industry will only look at the profit, whatever profit they are making or whatever enhancing their profit, they will only look at that. Safety research outcomes, these are the database generation is also important. We don't have too much data on this one. Capacity building, training, skill development, consultancy services to chemical and allied industries also important part. Different fields where you can go, whatever field you say, government field, CFD, research and development, CFD modeling, or you can so for all types of industries, chemical related industries. For all these ones, process safety research is important, which is what is lagging in India. Because if you see, even if you Google all IITs, NIT's website, you will see that very less faculty members are working in process safety research. And very few are there who are working in only exclusively in process safety field. Some of the institutes that work in this is like CLRI is there, NEERI is also there, NCL, IICTE, even IIT Gandhinagar has separate department, safety department. Then Cochin University, IIT Roorkee is also having disaster management department. Even center is there, Center of Excellence in Disaster Management. And SR Rotary Institute of Chemical Technology. All these are few institutes which are having these research areas. International, there are many, even though I have mentioned here two, but there are many organizations which have this research field. And if you see India and China process safety literature availability, what we have seen, we have just collected the literature on process safety to know, but China has published more papers, more accurate literature than the India. And significant data is available for them for types of accidents, region-wise distribution of accidents, accident distribution by industry size is also mentioned, and whereas Indian needs more literature on this to get the accurate data. My last 2 3 slides were future pathways for sustainable practices. Frequent industrial inspection, even though we have less manpower, but that is what is required, because once we visit that, we will come to know what is wrong in that one, and then you can guide them what can be what they can do to avoid accidents, because small things will lead to big accidents, so this should not happen. And at the basic level, if you take that precaution, then it's always better. Rules and regulations on process safety and risk assessment. Safety education, that is what we have observed, is that at educational level, at graduation level, it's very important. Process safety subjects, even projects are also important for on this field. Is what is required. Safety culture, management commitment is required. If management is committed to safety, obviously the others will follow to that one. Continuous monitoring is also important. Organizational learning, training, hands-on practice is important in handling all those chemicals. Improving automation, management, and reduce employees in hazardous areas. So all these will lead to sustainable practices. Why I'm focusing on this area when Dr. Shailesh informed me about this topic of FDP, I thought of putting this as a sustainable practices for the environment. Linking this industrial accidents, linking this risk assessment studies to, at the end of that one, it is linked to the sustainable practices, environmental sustainable practices. And obviously, development of software tool is also important field where we can have the 3D models, where we can give the what can be the what models can be developed to get the accurate estimation of the results. So in case of this conclusion, I will say that obviously my personal belief is on the disaster management plan than accurately estimating the consequences. Accurately estimating consequences is also important, but at the same time, tackling that disaster plays important role. Because what we have observed here is that continuous training, continuous monitoring, providing the basic infrastructure. So these are very important than assessing the accident. Like to give one example is that even if small accident occurs here in NCL, what we do is every quarterly we have sharing and learning session. Big auditorium, we conduct that one sharing and learning session, and that sharing and learning session is especially for the accident, that recent accident that occurred in that quarter. And the project leader or scientist of that lab will present that accident. Will present that accident, what happened, what causes for that one, and what can be done in the future to avoid similar accidents. That is presented quarterly for that lab, and the audience for this is all research scholars, all scientists, all technical technicians. All technicians are invited for that one. So, and this session is not to blame that your lab has accident, that lab has accident, that lab has big. It's not like that. It's just sharing and learning so that similar accidents can be avoided in the future. So these are the importance in that carry out here also. And mock drills are also there. Continuous monitoring is also there. So that is what is important than exactly assessing the situation. Industry inspection frequent, then training is over there, and PP is also infrastructure. One more important thing is infrastructure. We provide all basic infrastructure to them, like eye washers. Simple thing, but we see that eye washer should be there in that working condition. That should be there in that lab. Not only that, eye washer showers are also important. Firefighting facilities should be there. We have one trolley where all types of firefighting facilities are. So, and for each floor, for each building, we have that fire trolley. I will show you sometime. I will show you that photo also. So that is also important because tackling is important. And in addition to that, tackling, technical part is like new tools, techniques. Those are also the area where we can work on that one. Safety culture is important, and more focus on research in industrial safety is important. So this is my last slide, I suppose. Yeah, last slide. You can think outside the box, but don't allow hazardous chemicals to think outside the beaker. This is what the case is. So this is my presentation regarding this handling and storing of.
Thank you, sir. Thank you so much. It was such a fantastic and detailed presentations you have made for our participants today. Now we are already having second session here onwards. So I quickly request today's session coordinator, Mr. Dundera Deshpande, to please propose the vote of thanks.
Thank you, sir. It is my great honor and privilege to propose the vote of thanks on this special occasion. First and foremost, I would like to extend my deepest gratitude to Dr. Santosh P. Ghuge, sir, Principal Scientist at CSIR National Chemical Laboratory, Pune, for delivering such a insightful and enriching session during our 1 week online ATAL faculty development program organized by Department of Chemical Engineering, DYPIU. Sir, your knowledge and expertise and engaging presentation have truly enlightened us and provided valuable perspectives. I also take this opportunity to thank our Honorable Vice Chancellor, Sir, Professor Prabhat Ranjan, for his constant engagement and support in organizing such an impactful event. I heartfelt thanks to Dr. A.V. Patil, Madam, Director, School of Engineering and Management, for her visionary leadership and unwavering guidance that made this program successful. I also express my sincere thanks to Dr. Shailesh Ghodke, sir, Head of Chemical Engineering Department, for his continuous support and motivations throughout this event. My sincere appreciation also goes to our FDP coordinator, Dr. Utkarsh Maheshwari, sir, for his excellent coordination and effort in ensuring the smooth execution of the program. Last but not the least, I extend my gratitude to all participants, organizer, and technical team who contributed for conduction of this event. Thank you one and all for the patience listening. Thank you all.
Thank you,
Thank you.
sir.
Thank
Thank
you.
you. Thank you. Thank you so much. Now I request all the participants to kindly join the next link, because the next resource person is also ready. Sir, thank you so much. It was
Thank you.
great listening to you. Thank you, sir.
Thanks.
Good day, sir. Participants, kindly join the next link. Thank you.